Well, hello students. So we welcome you to our new lecture of electrostatics. We will start from where we ended in the last lecture. Due to some technical issues, we had to stop the previous lecture before completing it. Okay? So let us now complete it. So we are already studying about electric field. We are already studying about electric field. Electric field के बारे में हम पहले से ही पढ़ रहे हैं। तो फिर उसके बाद हमने इंट्रोड्यूस किया किसका कॉन्सेप्ट, इलेक्ट्रिक फील्ड लाइंस का कॉन्सेप्ट इंट्रोड्यूस किया। ओके, सो नाउ अभी हम क्या करेंगे, उन इलेक्ट्रिक फील्ड लाइंस के बारे में थोड़ा जानकारी हासिल करेंगे। वी विल स्टडी अबाउट some of the properties, some important properties of those electric field lines. Okay, let's us now start. So electric field lines, let me write electric field lines. Sorry, properties of electric field lines. Properties, these are very important things, huh? Properties of electric field lines. So let me check if it is covering or not. Yes, it is covering. So electric field lines, as you know, this is an imaginary, these lines are imaginary but these are real, but the concept is real behind it. So why are they imaginary? Why are we only imagining this real thing since they exist? But why so? Because only objects those are associated which they have an electric field associated with them can only feel those electric field lines, or they can only travel through the path sought by these electric field lines. So if it is a charge q, it is a bigger charge. Okay, it is a bigger charge and a positive charge. Now if we introduce a unit positive test charge here, then it is going to follow a path like this. It is going to follow a path like this away from it. So the path it is following is an actually electric field line. So whatever the path it covers or it goes through, so just assume that there are no such another electric field in its surroundings. Okay, it will follow a path and that path is our electric field line. So these electric field lines are also called force lines. Okay, these are also called force lines, but they are not very suitable to hear. They are not very comfortable to be heard of. So we use electric field lines or field lines, you can say. So first of all, let us now jump to the property. What is the property? These are smooth curves. These are continuous smooth curves. Okay, curves cover everything, even if it is a straight line or it is a spiral line, anything like that. Curves cover every term. If these terms cover every object. So these are continuous smooth curves. Like, see, what is a continuous smooth curve? Like this is a charge and its electric field line is like this. It is continuous and smooth. It is not like this. Okay, it is continuous but it is not smooth. It contains a lot of zigzags. Okay, it contains a lot of zigzags. This is one smooth line. So this is the first property, that these are continuous smooth curves. Let me check again. I think the light is fluctuating. So these are continuous smooth curves. And you can see why I wrote continuous. They do not have any breaks in between them. They do not have any breaks in between them. So that was your first property. That was your first property. Yeah, it may ask for any MCQ question in some entrance tests. So now come to the second property. For a positive charge, positive charge, for a positive charge, it goes out. There is a better term that will explain this. Just listen that I am going only to explain it and then write the sentence. For a positive charge, it goes out from it. Electric field goes out from a positive electric field line goes out from a positive charge. Okay. So I have written like this. But when we are progressing, we will be considering another term. That is what? That is radially outgoing. Okay, radially outgoing. So they go out from a positive charge. You can say for a positive charge it goes out from it. Okay, now let us come to the sentence. And for a negative charge it goes into it. For a negative charge it goes into it. So in this point, we shall be studying about its starting point and its terminating point. Like, if someone asks you, where does the electric field line start from? Or where does it get terminated? So, it or they, so write it like it. It starts from a source of positive charge. Source of positive charge. Okay, it starts from a source of positive charge and is terminated at negative charges. The negative charge. Okay, so let us now put, this is q, this is minus q, these are 2 points. So it is saying that it starts from positive charge and ends at negative charge. It starts from positive charge and ends at negative charge. And so many such lines you can draw. But remember the concept that it starts from a positive charge and ends at a negative charge. Okay. See, this is a continuous smooth curve starting from the positive charge and it's getting terminated at a negative charge. But this is no closed loop. If it had a closed loop, we'll study about closed loop in other sections of physics. But now it is starting from here and getting terminated here. It is not continuing like this. Okay, like this. It is not continuing like this. So it is starting from a positive test charge and is ending at a negative charge. Okay. Now just think, it is starting from here and getting ended at here, or you can say it is starting from this point and getting ended at this point. Now just consider that one of the charges is missing. One of the charges is missing, like this is plus q and this is minus q, and they are very far away from each other. They are very far away from each other's vicinity, such that it is not interfering the field of this charge and this charge is not interfering with the field of this charge. Okay, so for this, the electric field line start from positive test charge or positive charge and at infinity. The electric field line start from positive charge and end at infinity. And on the other case, you can say for a negative source of charge, electric field lines start from infinity and end at negative discharge. ओके, अभी आपको समझ में आ गया होगा आई थिंक। अगर वो दोनों पास पास होते तो आप ये बोल सकते हैं कि इलेक्ट्रिक फील्ड लाइन शुरू कहां से होता है, पॉजिटिव डिस्चार्ज से या पॉजिटिव चार्ज से शुरू होता है और टर्मिनेट कहां होता है, नेगेटिव चार्ज के ऊपर टर्मिनेट होता है। लेकिन अभी क्या क्वेश्चन है कि प्लस चार्ज ही है, एक जगह से प्लस चार्ज ही है और एक जगह माइनस चार्ज ही है। दे आर नॉट इंटरफेयरिंग विथ ईच अदर, कोई किसी के मामले में टांग नहीं अड़ा रहा है। जस्ट लाइक यू से इन हिंदी, मैं इसके काम में कोई दखल नहीं दूंगा और ये इसके काम में कोई दखल नहीं देगा। सो इस केस में आप तो ये नहीं बोल सकते कि स्टार्ट हो रहा है पॉजिटिव से और एंड हो रहा है नेगेटिव से, क्योंकि यहां तो नेगेटिव है ही नहीं। सो in this case you will say that it is starting from the positive charge and is ending at infinity, or it is terminating at infinity. And likewise in this case you will say the electric field lines are getting started from infinity and are terminating at this point. So what is certain for you, that it is terminating at negative charge, and in this case what is certain for you, it is starting from the positive charge. Okay, so it starts from a source of positive charge and is terminated at a negative charge. They do not form closed loop. So add these sentences, they it do not form closed loop. Okay, if for at a positive charge only, for a positive charge only, it starts from positive charge and ends at infinity, which means it doesn't end. Okay, now for the opposite sentence, for a negative charge, for a negative charge only, it starts from infinity, it starts from infinity and ends at negative charge, and ends at negative charge. So these are the sentences you need to understand very deeply, because these are very connected. So we completed the second property. Let us now check the third property. So what is the third property? It says that if you were given any field line like this, okay, you are given a field line like this. These are field lines, okay? These are field lines. Now, I have been asked, it is a point P. So, what is the direction of electric field line at this point? What is the direction of electric field line at this point P? So, how am I going to calculate that or find the direction? I have to draw a tangent to this curve at this point P. It is a tangent, okay, just like when you say sparshak, okay, this is a tangent. The direction of the tangent is the direction of the electric field at this point P. So now we have to convert it into a sentence. So अगर किसी भी कर्व, एक इलेक्ट्रिक फील्ड का कर्व हो, एंड यू आर गोइंग टू फाइंड द इलेक्ट्रिक फील्ड डायरेक्शन at that point it is only going to give you the electric field direction, not its magnitude or anything else, but it will give you the direction of electric field at that point, at that particular point, like this. If it is a point Q, if it is a point R, so what is the direction of electric field at point Q? Just draw a tangent. Just draw a tangent at point Q. Just draw a tangent at point Q. And the direction of that tangent will give you the direction of that electric field at that particular point, or at that point at which you are interested. So let us just convert it into a sentence. The tangent to a given point, the tangent to the curve, electric field curve. This curve means electric field line curve. The tangent to the curve at a given point specifies or gives you, specifies or gives the direction, the direction of electric field, electric field at that point. So the tangent to the curve at a given point specifies or gives the direction of electric field at that particular point, or at that point which on which you are interested to find the direction of the electric field. So it is a very important thing for you to learn that how are you going to find the direction of electric field. Okay, so which thing is going to help you? The tangent is going to help you. The tangent to the curve at a given point. So that point is important in this case. The point is important. So the tangent to the curve at a given point will give you the direction of electric field at that particular point, or at the point in which you are interested actually. So now we will come into another good concept, that no two field lines intersect each other. It is, so you see that it is a very small line, but it is very important line. Like we need to intersect two lines. Okay, it is a charge Q. It has an electric field line like this and an electric field line like this, and they are getting intersected at O. They are getting intersected at O. It is generally a point. So what is the point saying? That these lines can never intersect each other. These lines can never intersect each other. And why so? Because for a source of charge and its electric field, every point on that electric field has a special direction, has a specific direction. No two points in that field has that same direction. Okay, so at this point let us draw a tangent. There are two tangents possible at this very point. There are two tangents possible. So we can see that these intersections cannot occur. These intersections cannot occur because at this point electric field has direction about this way, and at this very point electric field has a direction about this way, which means single electric field at this point has two directions, which is not possible. So intersection of two electric field lines is not possible. Okay. So I think you get this point. You got this point actually. So we shall be coming to the fifth point. And this and after this, the points are not very important, but in fact you should know about these points. Okay. So what are those points? Like when you keep two charges in each other's vicinity, like do you keep two charges close to each other, maybe those charges are like, or maybe those charges are unlike. Okay. I just forgot that term. So maybe one of them are alike, like do both charges, one is a positive charge and the other is a negative charge, and the one and the other case both are positive charges, and the third case both are negative charges. So this is not that important what are the combination of the charges. So we'll say that is plus q, this is minus q. Electric field lines are from this side to this side. Okay. Now, if they come any closer, that means the curve of this line will be bending more. So it will be bending more. So we can say that in the fifth property, we can say they have an ability to be contracted lengthwise. Field lines have the ability to contract along their length. Along their lengths. So see, when they are contracted, this can happen only in case of if one is positive charge and the other is negative charge. What means they are contracted? That means the charges are getting closer. The charges are getting closer, which indirectly saying you that these charges attract each other. These charges attract each other. If they are being accelerated towards each other, that means they are attracted to each other by some force. So in this point also you can say that a positive charge attracts a negative charge and vice versa, or you can say unlike charges attract each other. So this point explains a lot of things, or those explanation make you this line. Okay. Now we are going for the other point. Like see, this is a plus charge, this is a plus charge. See, electric field lines are like this. No, this is not the good way. So these are electric field lines. Are you getting it? For a positive charge, you saw these lines going outward from that charge. Okay, you saw these lines are going outward from that charge. So you can see that the field lines of one charge are avoiding the field lines of the other charge. You can actually see this. So we can say that they have a tendency to expand laterally. So they have a tendency to expand laterally. They have now if we take closer this, we bring it closer to this, they will expand laterally. Or if we keep it that way, and they will go far from each other. That means the distance between those two lines from each other, they are just expanding themselves laterally. So they have a tendency. They have a tendency to expand laterally. To expand laterally. And from this point, we can also understand that like charges, that means positive positive or negative negative charges, will repel each other, will repel each other. That was what I was trying to say from this diagram, that, and from the previous diagram, that unlike charges attract each other and like charges repel each other. So we have reached the sixth property, and we shall be soon be studying the seventh property. What is a seventh property? What is the seventh property? They are always normal to the surface of the conductor. So these lines of force are always normal or perpendicular to the surface of a conductor on which the charges are in equilibrium. So what is the seventh property? Seventh property is electric field lines, or I can write they are always perpendicular. They are always perpendicular to the surface, to the surface of a conductor, in which charges are in equilibrium. Equilibrium. Now I shall be turning you to the eighth point. So from the previous point, you see that they are always perpendicular to the surface of the conductor, and this point is going to be elaborated in the next few lectures. Why is that so? It's a different concept. So coming to the eighth point, what is this eighth point is all about? So what is the strength of an electric field? What is the strength of an electric field? Like a charge is given and other charge is also given. What is the relative strength in between them? Which means which charge has a stronger electric field? How are you going to confirm it? Like let me just do a diagram here. Like this is a charge, okay? We are experiencing or we are observing its electric field at a far distance, okay, at a far distance. So these electric fields are like this. These electric fields are like this. They are parallel to each other, okay? They are parallel to each other. And you have another electric field like this. These are also parallel to each other. These are also parallel to each other. Now you can actually tell from this difference that which electric field is stronger relatively. Okay. Which is stronger? Now which has a larger light density, which has a larger